Hello, I'm Professor Sid Morris, the author of the online book Topology Without Tears, which can be found on the web at www.topologywithouttears.net. This is the first in a series of short videos which supplement my online book. However, the videos do not replace the need to study that book. Indeed, to learn and understand topology, you need not only to read the book, but also do a large number of exercises for yourself. Reading someone else's solutions will not suffice. In this video, I want to correct a misunderstanding about pure mathematics. Often, mathematics is subdivided into applied mathematics and pure mathematics. The tendency of many people is to assume that this means applied mathematics is useful and pure mathematics is useless. This is very wrong. In applied mathematics, we generally start with a real-world or practical problem which we want to solve. For example, if we are fishermen, we may want to be able to predict tides, as these impact on the behaviour of the fish we want to catch. By tides, we mean the alternating rise and fall in sea level. We recognise that tides are caused by the gravitational pull of the moon and the sun, so we are required to calculate the orbit of the Earth around the sun and the moon around the Earth. When we have done this, we have solved the real-world problem we started with. In pure mathematics, we start with a set of axioms or rules, and using logic, we deduce or prove propositions and theorems from the axioms. This results in a theory associated with the axioms. For example, if we start with a definition of a topological space, we can derive a vast number of theorems. The theory we develop turns out to have many applications, and often these are unexpected. The definition of topology, which we start with, seems very far removed from the world of finance. However, topology is vitally important in the advanced study of finance, and usually graduate students in finance are required to study topology. A second example involves prime numbers, that is, positive integers which are not the product of two other positive integers. The study of prime numbers dates back well over 2,000 years and is curiosity driven. For example, we note that between 1 and 10, the prime numbers are 2, 3, 5, and 7. So we might ask, what percentage of numbers between 1 and 100 are prime numbers? Or between 1 and 1,000? Or between 1 and 1,000,000? Indeed, what is the percentage of prime numbers in the limit? This leads us to the powerful prime number theorem, which provides the answer. It says roughly that the proportion of prime numbers between 1 and the number n tends towards 1 over log n. While the study of prime numbers might be fun, it seems to be of absolutely no practical use. But nothing could be further from the truth. In the study of prime numbers, one realizes that while it is relatively easy to find large prime numbers, and by large I mean extremely large, it is very difficult to find the prime number factors of a very large number. If the number is large enough, those prime number factors cannot be found even using super-fast computers in a lifetime. And this is the basis of what is called RSA cryptography, named after its discoverers in 1978, Ron Rivest, Adi Shamir and Len Edelman. When you use your credit card to buy something in a shop, your data must be sent securely to the bank. It needs to be encrypted. The method used is generally RSA cryptography, based on the difficulty of finding those prime number factors of a large number. So prime numbers play a vitally important role in our everyday life. So in our two examples, we started with a set of axioms or definitions and developed a theory. And the theory turned out to be of great practical importance in terms of real-world applications. So the difference between pure mathematics and applied mathematics is really just the starting point. In applied mathematics, you generally start with the real-world problem you wish to solve and proceed from there. In pure mathematics, you start with axioms and derive theorems and create an entire theory. In many cases, the theory will have practical applications, but often these applications are not discovered until decades later. So pure mathematics and applied mathematics can both be very good mathematics, and both can be very useful, but their approach is very different. I hope this video has helped you to understand pure mathematics a little better.